Hello everyone, in this video we will watch how to find the integral of tan x. So firstly we know that tan x can be written as sin x divided by cos x. Substituting this in the given integral, we get integral sin x divided by cos x with respect to x. The next step is that we know that the integral of cos x is sin x, and since the sin x term is given in the numerator, by the method of substitution, we are going to solve the rest of the sum. So we will consider let cos x be equal to t. Doing so, we get the further steps of this method is to differentiate the given cos x is equal to t with respect to x, which gives us minus sin x equal to dt by dx. Let us cross multiply. That gives minus sin x into dx equal to dt. Bringing the minus sign towards the right, we get sin x into dx equal to minus dt. As you can see, this part of the equation is similar to the numerator of the given integral, so we're going to substitute this part in the given integral. That implies integral minus dt divided by cos x becomes t. Now we know that integral of 1 by x with respect to x is log x. Similarly, integral of 1 by t with respect to t will become log t. So that implies integral minus sign towards out, so that will be left with this form. That implies minus integral 1 by t with respect to t becomes log t plus c. Let us substitute the value of t again. Minus log of cos x plus c. Now the next step is to write cos x in the form of secant x. So we know that cos x is 1 by secant x. Substituting that, we get minus log of 1 divided by secant x plus c. Now using the properties of log, we know that log m by n can be written as log m minus log n. So that implies, let us keep the minus sign outside, it becomes log 1 minus log of secant x plus c. We'll remove the brackets and multiply minus sign throughout. That gives log of secant x minus log 1 plus c. We know that log 1 is 0, so that implies log of secant x plus c. Therefore, integral of tan x is log of secant x plus c. Let us go through this again. Now, first write tan x in the form of sine and cos, so which gives us tan x equal to sin x divided by cos x. Write this in the given integral. We get integral sin x divided by cos x with respect to x. Now we can see that the differentiation of cos x, it's given in the numerator, not the exact form, but then we know that sin x is given, so we'll be taking cos x is equal to t. Differentiating, we get minus sin x equal to dt by dx. Cross multiplying and shifting the minus sign to the other side, we get sin x into dx equal to minus dt. This is of the form of the numerator, so substituting, we get minus dt divided by cos x is replaced by t. Now we know that integration of 1 by x with respect to x is log x. Similarly, integration of 1 by t with respect to t will be log t. From this, we're going to take the minus sign out, then it will give us the form of integral 1 by t with respect to t. So minus, using the formula log t plus c. Now substituting the value for t, from here we get minus log of cos x plus c. The next step is we're going to write cos in terms of secant. Well, you might ask why we can't just leave it here, but then you know that there is a relationship between secant x and tan x from the second property, which is secant square x minus tan square x. So in that way you can remember that whenever there's a tan term, we're going to write it in terms of secant x. So yeah, that's what we're doing here. Cos x in terms of secant x is 1 divided by secant x, writing it over here. And then we're going to be using the logarithm property, that is log m by n equal to log m minus log n. That becomes, keeping the minus sign outside, log of 1 minus log of secant x plus c. Multiplying plus minus sign throughout, it becomes log of secant x, minus and minus becomes plus, minus log 1 plus c. We know that the value of log 1 is 0. That implies log of secant x plus c is the integral of tan x with respect to x. So this is our final answer. Integral tan x with respect to x is equal to log of secant x plus c. Thank you for watching this video, and if you have any other video requests, just comment down below and I will make a video shortly on that. Thank you.